Okay, so similar to Unit 4, number 10, Unit 4, number 5 is also a challenging problem. So right here, we're talking about a piecewise function, and that means we're going to be talking about limits, and that means we're going to be talking about derivatives. So, as I said, the deeper we get into these units, the more challenging they will become. Okay, so just make sense of this before you dive into it. We're talking about the depth of the river at a certain point is modeled by the function. Here's the function, where t is measured in hours. So what this is saying is, it's this function from 0 to 6 hours, and it's this function from 6 to 10 hours. We want to talk about the depth of the river over a certain amount of time from 0 to 10. Okay, so w prime of 8, using correct unit to explain the meaning. So in this case, we're looking to take the derivative of the second function. So we can think of it like this. It's just literally going down to this function and finding w prime of 8. Okay, so we want to take the derivative. The 10 goes away. We bring the 2 down. This becomes negative 2/5. Normal inside, so t minus 6. I'm going to leave it at t minus 6, even though I have this goes down to 1, then times the derivative of the inside, which is 1. So it's really a more basic derivative than it seems. If you want to, you can always expand this and multiply it out and do it that way. But, no use to chain rule is fine. Then I evaluate this at 8, and this becomes negative 4/5. Okay, so negative 2/5 times 8 minus 6, or times 2 becomes negative 4/5. And that means the depth of the river is changing. Okay, at time t equals 8 hours, the depth of the river is changing at a rate of negative 4/5 foot per hour. That's going to be a whole, let's say this is a 3-point section. This will be 1 point, and this will be 2 points. So it's essential that you do this, and you use the units, and f over h is fine as well. Okay. Part B. The graph of w prime of 8 is concave down from 3 to 3.5. Use the line tangent to the graph of w at t equals 3 to show that w of 3.5 must be less than or equal to 9. Okay, so maybe we understand this, maybe we don't, but the fact of the matter is, if we have the coordinate point W3, right, and we know that from 3 to 5 it's concave down, we know it looks like this. So our tangent line is going to give us, okay, so I have created these PDFs for you and these Word documents for you, and as I said, I took them directly from the AP Classroom, so and I'm retyping them. So there's going to be 1 or 2 typos, and here's a typo on the graph, on the equation, on the question, sorry. I have it written as the graph of w prime of 8 is concave down. What that's supposed to be is the graph of w. So simply the whole graph of w is concave down. Okay, so we know the graph of w is concave down from 3 to 3.5. We know this is the coordinate point 3, comma, and we already solved this to be 17/2. So we know this coordinate point exists. We need the equation of this line, and we need to show that 3.5 can't be or must be less than 9. All right? So we're going to use this linear approximation to show that this value right here must be less than 9. So we need the equation of the line. All right? And again, we do the same thing we've always done, which is we need our x, we need our y, and we need our slope. Well, we have our x and y. All right? There's our x and y. And our slope is going to be w prime of 3. So we evaluate the function. This is a non-calculator problem. So we're taking the derivative. Now we previously, so we need to take the derivative of this function right here. So let me write that down. 17 halves minus 3 halves cosine of pi t over 6. This is an unknown, this is a non-calculated question, so you know it's going to be unknown values, pi fourths, pi halves, pi thirds, so on and so forth. So this is our WT function. The derivative of this function, the 17 halves goes away. The derivative of cosine is negative, so this becomes positive 3 halves sine normal inside. Okay, normal inside times the derivative of the inside. So it's simply 10 pi 6. So there's our derivative. Our 17 halves goes away. This becomes positive because the derivative of cosine is negative sine. Normal inside times derivative of inside. Now we evaluate this at 3. Um, 3 pi over 6 times pi 6. 3 pi over 6 equals pi halves. And sine of pi halves is equal to 1. So this whole thing is equal to 1. Therefore, our W prime of 3, I'll write it right here, is equal to 3 halves times 1 times pi 6, which equals pi fourths. So that's our slope of the function at that point. Now, again, we're going over the whole problem. We have the idea that this is concave down. We have our coordinate point of 3, 17 halves. Leave it in fraction form for the time being. And they want us to show that 3.5 has to be less than 9. And we're going to use this function. So what we're going to find, we would guess, is that this function using the estimate is going to be less than 9 itself. Therefore, this has to be less than 9. All right. So now we just plug this in using xy, using our blah, 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 blah. Point slope, or point slope form, sorry. So y minus 17 halves is equal to my slope, which is pi fourths, times x minus 3. So that's the point slope formula we're using. Our x and y, 3 and 17 halves, our slope there. And then we're going to evaluate this at 3.5. I'm simultaneously going to move this 17 halves over, and I'm going to get pi fourths times 3.5 minus 3 is just 1/2. So I'm just going to leave this at 1/2 plus 17 halves. And this simplifies to y equals pi eighths plus 17 halves. So what we just found is the y value at this point right here is equal to pi eighths times 3.5 comma 17 halves plus pi eighths. So I'll give you some time to look at that and see why that makes sense or why it doesn't make sense. So did it make sense to you? 17 halves is 8.5. Pi over 8, I don't know what that number is, but I know that pi is not greater than 4. Therefore, I know that this is less than 1/2. So I'm looking at 8.5 plus a number less than 1/2, and I can absolutely verbalize this if I wanted to do it just like that. Therefore, this whole thing is less than 9. Therefore, the whole thing must be less than 9. Okay? You absolutely can verbalize that however you want to verbalize it, but just make sure you show your work. Okay, part C. Find the limit as x approaches 2, or t approaches 2, of wt minus t cubed plus 1/4 over t minus 2. First things first, we recognize the fact that, yes, we're doing limits, so it's the same type of multiple unit application that we were in unit 4, which will be unit 5, 6, and 7, same thing. So these will get more involved. But this looks like a really hard problem. Like, let's just start looking at this and say, geez, I don't know what to do with this. But let's just start out doing what we know to do about limits. And that is evaluating this at 2. Okay? So when I evaluate this limit, I don't have any other recourse but to evaluate the limit. So this becomes 2 over 2, so 0 in my denominator. And then I get 8 plus 1/4, but this must come out to, and that must, but I should be aware that it might come out to 0 over 0. So I evaluate this function at 2, because remember, we're from 0 to 2. So this is w of 2 is equal to 17/2 minus 3/2 cosine of 2 pi over 6, and that's it. So now I have to go back to my trig values, but again, I have my calculator available to me, so I could use this if I want to. 2 pi over 6 pi thirds. Pi thirds of cosine is going to be 1/2. So this is going to be 17/2 minus 3/2 times 1/2, or 3/4. And that comes out to blah, 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 blah. Okay, so that's 31/4. And when I plug this back into this of 31/4 minus 8 plus 1/4, I do get 0 over 0. So I should anticipate that happening. If I don't see it, maybe I just do it again. If it were a value, if this was 6 over 0, then it would be the limit does not exist. But because it does exist, or because it is 0 over 0, that means I can do more. But I don't know what we do from here. So what are we supposed to do from here? We don't know how to factor this or cancel this. And then we think, oh my gosh, LHOP. So we're going to take the derivative of the top, and we're going to take the derivative of the bottom. Remember, not evaluated at 2, but instead the w of t. So this becomes w prime of t minus 3t squared. The 1/4 goes away, and my denominator, which was t minus 2, simply becomes 1. So this is LHOP rule. And I'm just taking the derivative of the top and the derivative of the bottom, and then I'm evaluating it at 2 again. And this becomes w prime of 2 minus 12 all over 1. All right? And w prime of 2, we remember we've already found the derivative to be, pi fourths times sine of pi t over 6. So this is a simplified form. We evaluate this at 2. Oops, I'm way off here. Sorry, folks. And this becomes 2 over this becomes pi thirds. All right, this is 60 degrees. Therefore, this is root 3 over 2. Sine of 30 is 1/2. Sine of 60 is root 3 over 2. Therefore, y prime 2 becomes pi fourths times root 3 over 2, or root 3 pi over 8. That is just the W2. And then we remember we subtract 12. So our final answer,
what are you working on?
Is root 3 pi 8 minus 12. That is the limit as t approaches 2.